So far we've looked at the various forms of notation. We've looked at and or for inequalities. And there's one other thing that feature about inequalities that we should learn. And that is, you know, sort of a strange thing happens with inequalities. So here, this is a true statement, right? 3 is less than 5. If I were to add a number to both sides, using the addition property, I get 9 is less than 11, and that's true, and this is also true. If I were to subtract, so if I start again with 3 less than 5, and this time I subtract a 6 from both sides, and so I get minus 3 minus 1, and that is still a true statement. So adding or subtracting leads to true statements. What about multiplying? Well, again, let's start with that, and let's say we multiply by 6. So 3 times 6, 5 times 6. This is 18, this is 30, this is also true. How about dividing? Well, 3 less than 5, divide 3 by 6, divide 5 by 6, this is 1/2, and this is 5/6, and this is also true. 1/2 is indeed less than 5/6. Okay, so we have a lot of true statements. But let's take a look at this problem, right? We know that, let's take a look at this. So we start with 3 less than 5, but this time let's multiply by -6 instead of +6. And a very interesting thing happens. So here we get -18, and here we get -30. Now think about it. Which is bigger, which is smaller? We had 3 and 5, right? To the left is small, to the right is big. And now we have -18 and -30. So what's happened here? This was large, this was small, but when you multiply by a negative number, suddenly the two have reversed. So this has become large and this has become small. So at this step, so this is a false statement as written, right? That's a false statement because -18 is not less than -30. So when you multiply by a negative number, you have to do something, and that is to switch the direction of the inequality. So let me write this down. When you multiply, actually it's true for division as well. When you multiply or divide by a negative value, you must, on that line itself, switch the direction of the inequality. So really, this inequality right here should become that, and this then remains that. So let's do another little example. So for example, if I had 2 less than 4 and I were to divide both sides by -2, so let me write on the next line. So if I were to divide both sides by -2, then immediately I need to cross that out and change the direction of the inequality and then write my answer down. So this is -1, -2. Right? So remember that if you multiply or divide by a negative number, you must change the direction of the inequality. Okay, so now you sort of have the basics, and so let's take a look at solving a simple linear inequality. So solving a simple linear inequality. Okay, so solve 1. solve. Let's also say graph your answer, graph your answer, state answer in interval and set builder notation. So we'll do all things. We'll solve, we'll graph, interval, and set builder. So here is your simple inequality. 2x plus 1 greater than 4. Okay. You solve this just like you would solve any equation. So you would minus a 1 from both sides. So you get 2x greater than 3. Okay, and now be careful. Whenever you divide across like this, across that sign like this, you have to be thinking, am I dividing by a positive or a negative? If it's a negative, you've got to change that direction. But in this case, you don't have to do any changing. You just let it be, and you change. You just say, because 2 is positive, so 2x is greater than 3 over 2. Now this is the answer, right? This is the answer to the question solve. Okay. Now, it also says state the answer in interval notation. Okay, so I always start off by graphing, because from graph I can get to interval, and from the answer I can get to the graph. So here is my 3 halves. I decide if I want an open or a closed circle. So in this case it's going to be open, and x is greater, so I'm going to go to the right. Okay, so there is the graph of it. And if I get the graph, then it's pretty easy to get the interval notation. So here is 3 halves. At the right end is positive infinity, and this is parentheses on both sides. And it's pretty easy now to get the set builder as well. So remember, it's very simple. Curly brace, the letter x, because that's what we are using, a line, and then the answer. So there is all 4 ways of stating the answer. Now you don't have to always give all 4 answers. Just read the question and use whatever the question asks you to do. Let's do another one. Okay, and let's make this a little harder. So let's say we had 4 less than or equal to 1 minus 3x. So a couple of things I've done there. One is I've put the x on the non-dominant side in a sense, right? So, okay, so we can switch it around, as I said before. Make sure that you keep the pointy end pointing at the same stuff and the open end pointing at the open end stuff. So if I were to change things around, I would say 1 minus 3x. Remember now, all you're doing is moving the left side to the right and the right side to the left, and put the 4 on the right to make it easier. And the open end was towards the x, so I'm going to keep that open end towards the x and the pointy end towards the 4. So if I did that, as you see, then that's perfectly fine. Now let's solve this. So minus 1 from both sides. You don't change the sign because you're adding and subtracting. So that's a 3. And now I'm going to divide by a negative 3. Okay, so dividing by negative, switch sign. Okay, so must switch the sign. So this changes immediately right there to that. So on the left side I have x, and there is the new change sign, and on the right side I have negative 1. Okay, and so that's my answer. And let's represent that answer a couple of different ways. So here is negative 1, a closed circle on that one, and it's less than, so I'm going to go to the left. And if I get the graph, I can write the interval notation. So on the left end is negative infinity, minus 1, bracket, parentheses, and then set builder is simple, brace, the letter is x, line, and then the answer. And then we are done. All right, so that's a good start. We'll take a look at compound inequalities coming up.